Hi guys. Now in this video we discuss about Azure Storage. Uh, Next one is Azure File Storage. Cloud-based. It is cloud-based file shares like a network drive, used for lift and shift applications, shared file systems, replacing on-prem file servers. Protocol supported SMB NFS. Example: mount Azure file shares on Windows or VM, Linux VM, Windows or Linux VM. Next one is Azure Disk Storage. It is a black storage for virtual machines. Disk types, example OS disk and data disk for Azure Virtual VM. Disk type performance. First one is Ultra disk. It is for mission critical workloads. Premium SSD. It is for high IOPs and low latency. Standard SSD, balanced workloads. Standard HDD, backup and dev workloads. Azure Queue Storage. It's a message store for asynchronous communication used for decoupling applications, background processing, microservices messaging. Example: web app sends messages, backend processes it later. Azure Table Storage. Azure Table Storage is NoSQL key value storage used for semi-structured data, fast lookups, IoT data. Example: storing user profile metadata. Azure Storage account types. Type general purpose version 2, GPv2. Use case recommended for all storage. Type Blob Storage, Blob only workloads. File storage, premium file shares. Security in Azure Storage. Security encryption at rest, Microsoft managed or customer managed keys. Encryption in transit, HTTPS. RBAC plus shared access signature, SAS. Private endpoints, firewall and virtual network rules. Replication and redundancy options. Options: LRS, local single data center. Option ZRS, replication type across availability zones. GRS, geo replication. RAGRS, read access to secondary. GZRS, zone plus geo replication. Example: GRS for disaster recovery. LRS, replication and redundancy options. First one is LRS, locally redundant storage. How it works: data is replicated 3 times. All copies stay within a single data center. Uses a synchronous replication. Synchronous means immediately it replicate. Asynchronous means it replicate later. Azure data center, copy 1, copy 2, copy 3, like that it will copy the data. 3 copies it will maintain. By using LRS, there are some pros. Lowest cost, high durability inside a data center. Cons: no protection against data center failure. Suppose if data center is failed, so there is no protection and data also lost. 3 copies will be lost. Use case: so we use LRS for dev and test environments. Non-critical workloads we use temporary data. So it's like a temporary data. Only one data center it stores. So there is no. So critical workloads we do not load in the LRS. Only test and dev environment data only we just use. For that only we use LRS. ZRS, zone redundant storage. How it works: data replicates across 3 availability zones. Zones are separate data centers in the same region. Synchronous replication. This is also synchronous replication. Immediately it replicates. So any changes happen, it replicates immediately. Region. Mm, Availability zone 1, copy. 1 copy it maintain. Availability zone, one more second copy it maintain. Availability zone 3, third copy it maintain. By using ZRS, there are some pros. Protect against zone failures. high availability. Cons, slightly higher cost than LRS, not available in all regions. So it won't available in all regions ZRS. So only available in some regions. Use case, applications required high availability, then we use ZRS. Production workloads. For production workloads also we deploy in ZRS. GRS, Geo Redundant Storage. How it works? Data replicated, 3 copies in primary region, 3 copies in paired secondary region. Now we talked about region pairs. So that paired region copies. Asynchronous replication between regions. So primary region it is synchronous only. So immediately it copies. Secondary region, paired region it copies asynchronously. Primary region copy 1, copy 2, copy 3 it maintain 3 copies. Secondary region copy 4, copy 5, copy 6. So total 6 copies it maintain. Pros, protect from regional disaster. Even region goes down also, there is no impact. We can get data from the second paired region. Extremely durable. So it is so region, if region fail also, one more region will work. From one more region, we can get the data. Other paired region, extremely durable. So this is very durable. So our data won't be lost in loss. And cons, secondary region is read only. Yeah, data copied in secondary region, it is read only. So we can't directly see the data. Only so we can't modify the data. So only we can read the data. Highest cost. This is higher cost than others. LRS and ZRS compared to those, GRS is highest cost. Use case, backup data, business critical applications. So any business critical applications, so we have to use GRS. And also, if you want to backup, we can use the GRS. RAGRS, read access geo redundant storage. How it works? Same as GRS plus read access to secondary region. Primary region read write access. Secondary region read only access. Pros, read data even if primary region is down. Ideal for global read scenarios. So it is best for global read scenarios. So suppose you want data in other region and you want to read that data. So in that case, it is best for that scenario. That configuration it is better. Cons, more expensive than GRS. RAGRS is more expensive than GRS. GRS is more expensive than LRS and ZRS. Use case, reporting, global applications, DR with read access. If you want any disaster recovery that only required read access, then we use this. And global application, any global applications are there. So in that case, we use RAGRS. So any reporting, we want to save some other region. So in that case also we use RAGRS. GZRS, Geo Zone Redundant Storage. How it works? Combines ZRS plus GRS. Primary region, data across 3 availability zones. Data across 3 availability zones it copies. Secondary region replicated asynchronously. And primary region only it maintain 3 copies, and secondary region replicated asynchronously 1 copy. Primary region ZRS availability zone 1, availability zone 2, availability zone 3 it maintain 3 copies, and secondary region only 1 copy it maintain. Like LRS only 1 data center it copies. And the pros, zone plus regional protection. Even zone file also, region file also, there is a protection. Very high availability and durability. Cost, high cost, limited regional availability. So this is available in some regions only, not all regions. Use case mission critical enterprise workloads. Any mission critical enterprise workloads we use GZRS. RAGZRS, read access geo zone redundant storage. How it works? Same as GZRS, secondary region has read access enabled. Cross best resilience model, read access during regional outages. Cons most expensive option. Use case financial systems, government and compliance workloads only. For these only we use RAGZRS. Quick comparison table. Replication. LRS replication 3 copies. Zone wise it won't copy, only data center wise only it copies. Region one region only it copies. And read secondary it won't available. Cost is less. ZRS 3 copies it maintain in primary region, primary ZRS zone, primary zone, and secondary zone. Uh, Secondary zones. Zones are available. Two zones, three zones. It copies three copies, and zone wise it copies. So zones are okay available. Region regions. Yeah, one region it maintain in one region. Three availability zones. Read secondary. It won't available. Secondary region it won't copy any data. Cost is compared to LRS, it is high only, but compared to other GRS, RAGRS, GZRS, RAGZRS, it is less only. GRS, Geo Redundant Storage. Copies, 6 copies it maintain, and zone wise it won't copy. Only primary region it copies, and zone wise it won't copy. Secondary regions, two regions, it maintain two regions. And two regions data maintained in two regions. Read secondary also not available, and cost is compared to ZRS it is high cost. RAGRS it maintains 6 copies, don't copy any zones. Regions the two regions it maintain, and read secondary it is available. Compared to GRS it is high cost only. GZRS it maintains 6 copies. It maintain zone copies also. It maintain two regions, and read secondary it is not available. And so RAGRS and GZRS same cost. RAGZRS it maintains 6 copies, and zone copies also available. Regions, two regions it maintain. Read secondary also available. Compared to others it is very high cost. How to choose the right replication? Replication and redundancy options. Requirements cheapest LRS recommended. Zone failure protection ZRS recommended. Regional disaster recovery GRS is recommended. Read access during DR RAGRS is recommended. Zone plus region protection GZRS is recommended. Maximum resilience RAGZRS is recommended. Performance and scalability. Up to exabytes of data, millions of requests per second, automatic scaling, support Azure CDN for global access. Pricing factors, cost depends on storage type, access tier, replication option, data transfer, transactions. Hot plus LRS is equal cheapest for frequent access. Common real world use cases, website content storage, VM disks, backup and disaster recovery, data lakes, application logs, media streaming. Simple architecture diagram of Azure Storage. Table storage, NoSQL data. Queue storage, messages only. Disk storage, VMs. File storage, shared files. Blob storage, images and videos. Azure Storage account contains all this. So user and apps are accessible. Access to Azure Storage account. Storage account contains blob storage, file storage, disk storage, queue storage, table storage.